Madam, shall we start?
Yes, sir. We can start.
Okay, ma'am. A warm welcome to all the participants for the last day of the FDP. So we have started the FDP on 16th August 2021, and today is the last session we are going to conduct. So 1 week FDP on data analytic tools and visualization. So on behalf of Chalapati Institute of Engineering and Technology, Department of Computer Science and Engineering, I welcome all the participants for the day 6 of the FDP. So today's resource person is Dr. Shantala Devi. She is an associate professor. She completed her BE in Computer Science and Engineering from SDM College of Engineering and Technology and MTech in Computer Network and Engineering from Visvesvaraya Technological University, Belgaum, by securing first rank in the university. She has completed her PhD in the area of security for wireless sensor networks. Presently, she is having teaching experience of 15 years and currently working as associate professor in School of Computing and Information Technology, Reva University, Bangalore. And she is guiding 3 students for PhD. She has published 3 book chapters, 11 national and international conference papers, and 6 national and international journals. Her area of interest is wireless network, IoT, data science, behavioral science, etc. She is a member of CSI and IEEE. She is a member of COE, Cybersecurity, Government of Karnataka. She is a trainer for web development, cybersecurity, and many other tools. She has delivered many invited talks and resource person at VTU, FDPs, AICT, STTP training and workshops by various universities. Thank you, madam. Thank you for coming as resource person for the day 6 of this FDP. Over to you, madam.
Thank you, sir. Thank you for your kind words and introducing me to the audience. Good morning, all of you. I thank Chalapati Institute of Engineering and Technology for organizing this wonderful FDP on data analysis. And a special thanks to Ramchandra sir for speckless coordination for this FDP. Now let's begin with the session. Now, in this world where data is growing explosively, day in and day out, we are all aware that data analysis
Madam, screen is not shared, madam.
Okay, sorry. Now, sir?
Yes, madam, it is started shared. Yes, madam, now it is visible.
Yes, sir. Thank you. Yeah, sorry for the inconvenience. So we are all aware that this is the world where data is growing explosively and data analysis will be the future. We are all aware of the fad word called as big data, right? Everywhere we are dealing with big data. And when we are talking about big data, with data which is generated from enormous amount of resources, it is very hard to keep track of data, right? Interpreting the data and finding the meaning from this data is another significant task. Now, hence, we are all over here to achieve this objective, wherein we are trying to draw some insight into the data which is given to us. Okay, now how do we draw these insights of the data? Now, insights can be drawn from the data through various visualization tools. And we are all aware that visualization tools in data it forms very important component which helps us with trying to understand what exactly the data is trying to convey us, right? Now, in today's session, I would be continuing the discussion on visualization using Seaborn library, as mentioned over here. So I think yesterday we had Matplotlib. So today I will continue the discussion Using Python, Seaborn library will try to visualize a given data set and try to interpret what are the various ways in which we can see the data, right? Now, the agenda for today's talk is I'll be introducing you to the concepts of what is Seaborn, how it is different from Matplotlib, and what are the prerequisites in order to use Seaborn, and then how we can install Seaborn. I'll just give an oral preview of how we can install it and how we can import Seaborn and load the data set, and what are the various types of graphs that are possible. And we'll see how to visualize the data set, and then we'll conclude. Now, Seaborn is another Python library similar to that of Matplotlib, which is responsible for visualizing the data. Okay, so it is responsible for data visualization as well as exploratory data analysis. Now, why are we trying to prefer Seaborn over Matplotlib? Matplotlib, we have seen that it is difficult to figure out what settings are required to make the plots more attractive as compared to that of Seaborn. And also, we are able to achieve better visualization because Seaborn supports data frames, right? So that is why we are moving from Matplotlib towards Seaborn. Of course, we have a lot of other libraries like Bokeh and all, which we can use for interactive visualization. Now, the main purpose of visualization is to get a clear overview and clear understanding of the data that is available to us. So over here, we can see that graphs make it easier to explain data to non-technical people. Of course, technical people are able to grasp a lot of information just with the data that is given to them. But for non-technical people, we need to make it better presentation. And visually attractive graphs can make presentations and reports more appealing. Whenever we are writing or articulating any of the research document, or be it thesis or whatever, we are aware of how much graphs are important and how we use them for comparing information. Now, as already told, Matplotlib Seaborn is built over Matplotlib, and it has all the features of Matplotlib along with extra features which are part of Seaborn. It is more helpful in working with data frames. So let's move further. Now, where are the various places where we use graphs or charts or whatever possible? So you can see that there is a possibility of using graphs and charts when we want to depict a relationship. Now, and the type of graph that we would like to use over here is a scatter plot, or a scatter plot with a bubble size. And we have distributions which we need to depict. And in order to depict the distributions, we use bar charts, line charts, and scatter plots. And we also need to make comparisons. We are all aware where we use comparisons when we are working on a project, right? We compare it to the previous work that is already done, or a lot of other comparisons, right? So when we want to perform comparisons, we could use bar chart, or we could use line charts, we could use pie charts, and so on, right? Even in case of trying to give an understanding of the composition, we could use the stack charts and the bar charts, pie charts, water charts, waterfall charts, and there is heat chart, and there are many more charts as well, so which we will discuss in today's session. Now let's quickly move. Now let me stop sharing here, and I will move to the I'll be using a browser-based Jupyter Lab. Let me share it. Can one of you acknowledge whether it is visible?
Yes, madam, it is visible.
Thank you, sir. So you can just try to do it along with me, or you can just go through the variations that I will be working on. So over here, I'll be using one of the data set. So in order to load the data set in this particular I'll just take the sales data set which I have. So you can see that the sales data set is loaded over here. Okay. Now, if you want to use any of the library in Python, what do we first do? We first import the library, right? Import the library. Over here, we'll import Seaborn and create a object of it. And then we'll also import pandas in order to be able to work with it, right? So we have imported two libraries over here. One is the Seaborn library and the other one is the pandas library. If you are using the tool which is installed on your system, it could be an Anaconda tool or a Jupyter tool, whatever, you have to use the pip command or the conda command and install the relevant libraries. Okay, install the mandatory library is pandas, matplotlib. I'll just write over here matplotlib, scikit, and so on, right? So you can install that and then you can work with Seaborn. All those are mandatorily required in order to work with Seaborn. Now let's pandas as PD. There is okay. Now we have this particular data file or the data set over which we will be working for our Seaborn visualization. So let's try to load it. And how do we load it? We will create the sales and we will use pandas to load it. PD dot read and this is an Excel file which I am going to use in order to get the data set. So Excel and the name of the file will be given over here. So the name of the file is sales and this is the second version of the file which I'm using .xlsx. Okay, so this is the file that we will be using. So let's run this. So I got an error and let me check what it is. Okay, I need to have a dependency file which is required over here in order to load this particular Excel file. Let me install it. So I will use pip install open Python Excel. So once I have this particular dependency file, I'll be able to work on the Excel file. Okay, let me just copy this in order to save the time and paste it over here. Let's run this. Okay, it has successfully worked. So how do we check the check whether the data set has loaded appropriately? So we'll just check few lines of this particular data set. Over here, you can see in this data set, we have the row ID, order date. This is about sales, right? It is about sales wherein we are trying to sell some product and the priority of the sales and the order quantity whatever is the amount that is obtained, whatever discount is given, the mode of shipping, the profit that is obtained, the price, customer name, province in which it is being sold, the region, customer segment, product category. These are the various attributes associated with the data set sales. I hope till here we are good. Now we will actually start using the Seaborn library. So first, let's try to understand the relational plots. Why do we use relational plots? Now, when we use relational plots, we are trying to establish relationship between the various attributes over here. Okay, so the relational plot will take three parameters. One is the x-axis parameter, the second is the y-axis parameter, and the third one is the data set which we are considering. Right? Let's try to write a relational plot using the Seaborn library. Okay. Now over here, SNS dot relational plot. That is how we refer to the relational plot library. So over here, I will make sure you are spelling them correctly. So we will give x-axis to be sales and y-axis to be profit. We'll just try to understand the plot that is being generated over here. Y-axis is profit, and then we have a data which we have to refer is the sales. Now let's run this. So you can see we have got a graph which is plotted between sales versus profit. You can see that at times the sales is 0, and it is even the profit is negative, and at times the profit is positive, and we can see there is one dot over here which is depicting that it is some sort of outlier in this particular data. I hope this is making some sense. We are trying to plot a graph of sales versus profit, and you can see that the profit is 10,000 over here, and over here it is 20,000, and a lot of cluttering of data over here at 0, and even the profit is negative at times. Okay, so usually the sales is around, whatever be the product, it is around 2,000 to 4,000 quantity, and this is the amount of profit. Now let's try to make this more clear and more beautiful. And how do we do that? So let me take the same line and try to work on this. I will use an attribute called as hue. Hue means color, and let me try to introduce some sort of color over here. So I will try to depict more information over order priority, the priority of order. You have already seen that we have an attribute in the data set which represents the order priority. So let's run this and see what happens to our graph or the chart now. Over here, you can see that based on the order priority, whether the order is low, high, not whether it is not specified, medium, and critical, the same graph, which is plotted over sales versus profit, is giving more clear picture on the order of the priority that is based or that is given in here. Now let's move further. Now, if I want to change the representation, let's say all are depicted using circles. If I want to change the representation of all of these order priority, I can use another parameter, or I can add another parameter to the previous line. Let's try to do it. So over here, I will add another parameter called as style. Now, what does this style do? Now, the style helps representing the data in different form. Okay, let's see what is that form. I will put this styling again over the order priority. Now, let's try to understand the difference between the previous one and the current one. In the previous one, we have seen the entire distribution was colored based on the order of the priority, but all of them were represented using the same symbols or the legends. Now, over here, I am trying to use a different styling over the order priority, wherein low is represented by a blue circle, high is represented by a cross mark, not specified is represented by a square, and medium is represented by a plus, and critical is represented by a dimension. So you can see that the representation over here in sales versus profit has changed, and you are getting a clear picture as compared to that of the previous one. When you compare the first one, you had no idea about what is the order of priority of sales over here, right? Now, everything was in blue color. Only thing is you could understand that some sales were giving you no profit or zero profit or less or you were in negative profit, and that is made clearer with the help of hueing, that is adding color based on the order priority, and more clear picture is obtained when we use styling. These are the various ways in which we are able to represent the data. Now let's try to add in more features to it. Let me take the same line. So over here, let me first check. So over here, we have something called as ship mode. Okay, we had used order priority, we have used sales and profit. Let's use ship mode in this particular graph. So styling, I will replace it with shipping mode, whether it is used air mode, the regular air mode, or an express air mode, or it is delivered through road using a truck. Okay, let's check it out. So over here, what we see is another beautiful graph wherein it is a representation of sales versus profit, and you have two attributes which are, or two features which are helping making this data more clearer in understanding. Okay, depth of data visualization is increasing as and when we are adding more attributes to our graph, right, or the chart. So over here, order priority, all of them are represented using small circles, and the shipping mode over here is represented using a circle, a cross, and a square. So you can see that there is multiple features representation using the Seaborn library. Okay, let's try to move further, wherein you can see that it is looking clumsy, right? Let's try to make it better. How do we make it better? I'll just copy the same stuff and try to give different sizes to the data using the size parameter. So let me remove all the other features, and let me try to include size and work on a different feature now of the data set. So I'll work on discount. So over here, we are trying to plot a graph of sales versus profit, and I'm trying to use the feature called as size, or the parameter called as size, which will help me visualize discount. Let's see what happens over here. You can observe that we have different discounts possible. No discount, 5%, 10%, 15, 20, and 25. You can see during the sales how much discount was given, and you can see that the data is represented using different circles based on the discount that is given to the sales, and it is directly relevant to the profit or directly relational to the profit. Now to the size itself, you can see if they're still small, we can increase the size. I'll just do it over here. Okay, just to be able to differentiate between the first one and the second one, I will just copy it and use the attribute or the parameter sizes, and I'm setting the size from 25 and up to 200 size. So you can see that the size used for representing the size of the circles used for representing the discount changes so that it is more clearly evident, and you can use any size in order to represent your data based on the data that you have. I hope this is clear. Over here you have small circles representing discount for over sales versus profit. We can customize it or set it to a larger size with the help of a new parameter introduced into a relational plot, which is called as sizes, wherein I'm setting the starting size to be 25 and the ending size to be 200. I hope this is about this scatter plot. So let's have a quick understanding. So we have taken the sales data, wherein we have tried to depict the data in the sales of sales versus profit. And over here, we can see how data is represented. Then we have tried to add a new feature to it, that is the color. And even within the color, we have tried to add the styling to it, wherein we are representing different values using different legends. And then we have again multiple features that could be represented. Order priority and ship mode we have represented, and then we have tried to change the size of the circles that are used to represent the data, and we have tried to even customize the size of the circles. So these are the various ways in which we can work on the scatter plot. Let's move further to the line chart, which is most important, and we'll work on line chart now for representing the data, right? Now creating the line chart with Seaborn library, and let's see how it is done. We will use the same sales data and use the same command. So over here we have the Seaborn library relational plot. I will use this same way of creating the line chart. So SNS.relational plot. We will try to work on the date on which the order was given for a particular product. This will be my x-axis, and the y-axis is the sales on a particular date. What was the sale? And then we have data which has to be referred for this particular graph, which is represented as sales. So this is the object I'll be referring to. And then the kind of plot, I will use the parameter kind. So kind of plot that I need over here is the line plot. Okay, so let's see what we will be getting. Let's run this. You can ignore any of the warnings that it is taking a little bit of time over here. You can see that. Okay, it took a lot of time because of the size of the data set. So over here, you can see that there are two line graphs that are superimposed on each other. One is the order date, and the other one is the sales that is superimposed over here. So you can see there is no clear distinction between the years or the dates over here, and we are representing this against the sales, right? So how do we make it look better? I hope this is clear. We are trying to draw a line graph or a line chart, and let's try to work on this. So rather than working on a date, let's extract the years from here and represent the unique years over the sales. Let's try to do that. Sales, from the sales, I want to extract only year. Okay, so I'll just give as year. So this is the column I'm creating now, is equal to sales, and I want this from which attribute? I want it from, sorry, and order date. Okay. So what I'm doing basically over here is I'm trying to, because there is a lot of overlap of data, I'm trying to simplify the way in which the data can be represented by creating a new column called as year, and I'm extracting this year from which attribute extracting it from order date. Okay, I'm extracting it from this particular parameter present in the sales data set. So let's run this. And I will try to get all the years that are unique, which are now, let's try to get all the years which are unique. So I'm getting an array of 4 items in it, and these give me the unique years present in this particular data set. Now let's take the same old line of ours. How do I do this now? Okay, I'm trying to draw a line chart, and over here, rather than having order date, I can easily replace it with a year that I've created. That is a new column that I've created, and rest can be as it is. Now the second one is the sales, and the third one is third parameter is the data from which I want to extract this information, and the type of chart that I want is a line chart. Let's run this. Let's see. So over here, we can see that we have obtained a better graph as compared to the one which was clumsy in the previous representation. So we have this graph over here. We have this line graph, but you can see that there is some sort of spreading around this line graph. Now, what is this spreading of the line graph? Can anybody say what is this shaded area? Now, what has happened over here is a mean of the data is calculated and the mean is represented by the line, and the shaded area is the confidence interval. Over here, this is called as confidence interval of the data. Okay, it is around 95% positive and negative. Now, how do I just get a confidence in, or how do I eliminate this confidence interval and just get a line? So what do I do over here? I take the same previous line and work on it. So the confidence interval parameter I will add over here, which is represented as CI. I will set it to none. So over here, you can see that the confidence interval is eliminated. Of course, the representation of the graph has changed slightly, but it is again better than the previous one. So over here, in the previous case, the estimator was taking a mean value, right? And in order to remove the mean value and give an exact value, we have to use the estimator and set this particular estimator to none. So let's do that. So I want to work on representation of this particular line graph in a better way. So I will use, I hope till here we are clear. I will use the hue and I will pass the ship mode as a parameter to it. The mode of shipping as a parameter to this particular line graph. We can see that the data that is represented is in a more better way with respect to the ship mode. So over here, there are three ways of shipping the products. One is regular air and the delivery truck, that is by road, and the third one is express air. Now, when you compare the sales with that of the year, you can see that regularly delivery truck is used for delivering the data, delivering the product. And then we have other two possibilities of shipping, which is regular air and express air, which is used infrequently as compared to that of the delivery truck. This is another way of representing using the line chart. Okay, you have the year and the sales, which you were representing all this time with the help of the line chart, okay, or the line graph. Now, what we have done is we have included another parameter or induced another parameter in order to get the depth of this particular graph which was being depicted. Now, let's move further. Let's try to introduce another parameter over here, which is called as style. I'll do this over the same plotting that we had done previously. So we have style. Style can be set to any of the parameter. Over here, we'll set it to the product category. Let's see. There is a spelling mistake for category. Okay. Over here, we can see that we have tried to make the data or the chart look more better for our data. So these are the possible years and these are the possible sales, and the mode of shipping used is represented using a blue, orange and a green line, and then the product category in turn again is represented using a solid line, a chain line and a dotted line. So you can see that we are trying to introduce more and more details into this particular line graph. Let's move further. It's really scary to see this particular shading, right? We'll try to remove that shading. Let's see how we do that. Over this, I have already told how to do it. Let's do it for this particular representation of chart. So I will set the CI equal to none. So this will give us a better representation of just the line graph that we are interested in. Usually we find such line graphs in our research articles, right? So this is what is required for us. So let's see various other things as well. I hope we all are doing good. We are able to, I hope you all are able to understand. Now, let's try to understand how to use the columns. So rather than using style, what I will do is represent the above data in a clearer way, wherein each of this is represented separately. Instead of style over product category, I will use column. Let's run it. So what do we see over here? We can see that 3 different charts are created column wise, and the first chart is represented, or the first line graph is representing product category of office sales, right? With respect to shipping mode, one is the delivery truck and the other are express and the regular air. And the second graph or line chart is representing the technology as the product category, and again the shipping mode can be represented. The sales over here is kept common. Okay, it is the y-axis is common and the x-axis is repetitively drawn again and again, depending upon the number of product categories. Now there are 3 product categories over here. One is office supplies, technology, and furniture. Now, I hope this is clear. What we have done is we have split the data representation of this one. We have retained the shipping mode, but we have split this particular data with respect to the other 3 possible values of the product category. So we have used the column parameter in order to do that. Now let's try to extend this particular feature. How do we extend this feature? Let's see that. I'll take the same plotted graph of ours and try to extend this feature. So rather than product category, which is just giving me 3 simple graphs or 3 values, I will take attribute which has more values, which is taking more values. Let's say a region in the data set takes more values. Regions obviously has many regions, right? Many values, right? So we will take this. Let's try to run it and see how many possible plottings happens. Oh, okay. We have multiple plottings that are happening over here. So very feeble and not visible over here. We have, let's count this, 1, 2, 3, 4, 5, 6, 7, and 8. There are 8 graphs that are plotted. That means there are 8 regions, and all these 8 regions, we are representing sales over here. What are we trying to do? The x-axis is the year and y-axis is the sales, and we are representing the data column-wise for each of these regions, and trying to understand the shipping mode that is used for each of these regions. You can see the first one uses a lot of truck mode of delivery, and the others use a little bit of less as compared to the first region. Now, how do we put this in a better way? Let's try to put it in a better way for clear understanding. So I want, let's say, around 2 graphs or 3 graphs in a particular line or in a particular row. So how do I do that? I use an attribute called as column wrap. Column wrap is equal to, let me set it to 3. Okay, that means the first 3 graphs should be in first line or the first row. Second row will have 3 and the third row will have 2. Or since it is, let me give this. Let's see what happens. So over here, you can see that first 3 graphs, now it is clear as compared to the previous representation. Now over here, we have first 3 graphs represented in one row, second 3 graphs represented in second row, and the third, and the remaining 2 represented in the third row. So this is how we can use column-wise representation. And if there are too many graphs, we can just try to wrap the data and put it in an appropriate way. Now, this is all about line graphs or the line charts. Shall we move further? So what we will do next is we will try to plot using different facets. So this is again another nice way of representing the data. Let's try to understand this. Dividing the plots using facets. Now let's try to divide the plots using facets. Let me comment it. Now, how do I do that? I'll use the Seaborn library and use the relational plot and provide 3 parameters which are very basic to it. X-axis has the sales and Y-axis will have the profit. And then I will draw the data from sales object. So let me close this. That is why it is still not changing the color. Then let me represent a column is equal to customer. Let's take another attribute from your data, customer segment. And let's close this. Let's see how the data is represented. Fine. Now, what we are trying to understand through this graph is the sales that is happening in this particular business. Who are the main customers who are buying this particular product? That is what we are trying to understand over here. So over here, sales versus profit is represented, and the customer segment is business. You can see that there is lot of cluttering at clustering at 0. And then we have regular consumer who is buying, individual that is, and we have corporates, and this is the representation, and home office. Now you can see there is a lot of scattering of data when we are talking about small businesses and corporate customer segment. Now let's try to put more insights into this particular representation of data. First, let me make this more clearer by using column wrap. All wrap equal to, I will set it to 2, run this, and then yes, I have 2 graphs in each row, making the view more clearer as compared to that of the previous representation. Now let us add a little bit of coloring to this so that we understand this particular scattered plot in a better way. So how do I add the coloring? Coloring is added using the hue attribute. Hue stands for coloring. I will color this on the priority of the orders that is received. Priority. Let's run this. You can see that there are around 5 priorities over here. One is the low priority, high priority, a priority in which sometimes it is not specified, and we have medium priority and the critical priority. Now you can see that the customer segment, small business, lot of blues, that is low priority, lot of oranges, that is high priority, is more over here, and over here you can see it is a blend of all of them. And then even in case of home office, it is a blend of all of the priorities. Now let's try to work on a different feature or an attribute for coloring over this particular customer segment. Now you can see how slowly we are getting into the depth of this particular data. Started by plotting sales versus profit, and then we added the customer segment to it. That is the third attribute also being represented here with respect to sales and profit. And the fourth attribute is what? Order priority is added, which is trying to help us differentiate the various colorings. Now let's change the hue to shipping mode. Let's see what happens, because we are more aware of what's happening in the shipping mode, right? So shipping mode, we have 3 shipping modes possible. Let's see the same representation over here. You can see when the customer segment is small business, truck is more used for delivery. Even in case of an individual consumer, delivery truck is used for delivering the product. And over here it is scattered again. Delivery truck is used more here. I think blue is more that is regular air in case of home office. So there are various ways in which we can interpret this particular data. This is about it. Let's try to see further. Okay, whether we can add both row and column to this. Let me take this particular line and make it little more complicated chart. Okay, over here we have column. Column is representing what? Customer segment. Let me add product category along with the ship mode. Why do we let go that? Let me remove this. let me put a row, and row will have what type of data? It will have, we had deleted something, right? Product category. Category. Yeah. Make sure you use the correct spellings of various attributes in your data set. So let's run this. So what I have done over here is try to add more and more features for representing the data. The first thing is the X and Y over this particular data set, that is sales versus profit. And then I am trying to induce one more attribute to it, which is customer segment, column wise, and row wise product category, and the coloring I'm trying to provide here is the ship mode. Now let's see what's happening to the output. You have multiple graphs or charts that are generated. So product category, office supplies, and customer segment is small. So you are getting a representation along with the shipping mode, row wise and column wise as well. Okay, you're trying to include more and more of data or depth to your particular data. Now, I hope this is clear about the scatter plots and its various ways of representation. So this is trying to plot using various facets for the data. Now let's try to move to the next segment, which is categorical data representation using scatter charts. Categorical data, let's see our data set first and then understand what is categorical data. How do we see the data set? Over here, you can see this is categorical data. Now, in case of order priority, you can have low, high, medium, whatever. So various categories are present over here. In case of shipping mode, you have multiple categories: regular delivery, regular air, delivery truck, and the express air. And even in case of customer segment, you have a lot of categories, product categories, and product catalog categories, and so on, right? There are multiple categories that are possible. For all these categorical data, what are the various ways in which we can represent? We'll just check it out. Now let's see how to do that. I will use different way to create a categorical plot. Earlier, I was using a different way of plotting the data. So I will use here categorical plot. What was the earlier one? Relational plot I was using, isn't it? So I was trying to establish relations. So over here, I will try to establish the various categories. So even in this case, I will supply x-axis, and x-axis, let it be the ship mode, the modes which I'm using for shipping, the product, and then let sales be the y-axis. And I am trying to work on the data set. Now you can see that this is another way of representing the data. So the x-axis is taking regular air. There are three categories which are possible over here, and all the three categories are represented using using blue, orange, and green color. And initially there is a lot of the data is very dense, and as it moves further in the sales, it gets scattered. So this representation is for categorical data. Now, I do not want such huge width to be given for my particular data representation. I want to use a different way or different styling for this particular representation. So what we can do is add a new parameter to it called as jitter. Jitter will reduce the width to a single line. So I will set the jitter to false. So when I set the jitter to false, what am I getting over here? I'm getting a single line representation for each of the categories in the x-axis. So regular air is represented again with the blue line, and delivery truck shipping mode is represented using orange, and so on. Now, let me try to include some more feature to this particular categorical plot. Now, what is that? Let me take the same above line. I can write a query over here which says, I'm trying to write a query which runs over this particular data set. So data equal to sales dot query. Okay. I am trying to add more feature to this particular data which I'm working on. Okay, so I can say I want to represent, or I want to print in this particular chart all the values with the profit greater than some 1,000. Okay, so what have we done over here? I am trying to represent a categorical plot, and with X being the shipping mode categories. There are 3 categories over here, and we have Y axis representing the sales. And this data set, on this particular data set, we are writing a query and trying to find all the values for the attribute profit, which is greater than 1,000. And of course, this we are aware of what happens when we give jitter is equal to false. Now let's run this and try to see what is happening here. So we will be getting all the values represented over here with profit greater than 1,000. Okay, with profit greater than 1,000. Now let us get a clearer picture of this. So let me take the same graph. Let me take this line. Okay, I need to make, or I need to differentiate between the 2 graphs which are trying to give me a profit which is greater than 1,000, right? You can see that it is not very clear as compared to the previous representation. So what I can do over here is I can say the way in which I represent the data can be of the kind swarm. Okay, I will say I want it to be swarm, SWARM. I want the data to be represented in a swarm form. So let's see that. Plot kind swarm is not recognized. Somewhere I've done a mistake in spelling. Okay. These are all inbuilt and available. So you can see this is a representation, another representation in swarm format for all the sales which has fetched a profit greater than 1,000. Okay, so with respect to the shipping mode, right? So this is another way of representing the same information, and it is giving a clearer view as compared to the previous one. Now, how do we represent the same horizontally? This is vertical representation, right? We want horizontal, let's say horizontal representation. How do we do that? Only thing we need to do is, it is an easiest way of doing it. Replace X with Y and Y with X axis. So I'll just replace sales to be X value and shipping mode to be Y value. And let's run this and see the difference in the graph or the plotting that we are obtaining. So now we are able to represent the same information horizontally. This marks the completion of our categorical charts generation. I hope till here we are able to understand what is scatter plot, line charts, and we have seen different facets of representing the scatter plots, and then categorical data as well. Let's move to the next type of chart, which is box plot chart. Now this box plot chart we use in order to represent again categorical data. And this helps us understand the overall distribution of data, and even if there are any sort of outliers present. And this distribution is over the curtails. We need to understand what the median is, what are the various outliers in the data. Outliers are some irregular behavior in the data. And this sort of representation of box plot chart helps us understand this the data very clear if in case there are a lot of outliers present. Let's try to see what is this particular box plot chart. Now we'll use the same way of creating the box plot chart. Let me just write one comment over here. Creating box plot chart. Now let's create it. I will use the Cborn library. I'll refer to it using SNS, and then I'm creating a categorical plot of type box plot, and I need to supply an x-axis which is let's say it's the product. We'll again refer to the sales data set itself. So over here we have product category, and the y-axis is shipping cost. And we are referring to the data set sales, and the kind of chart or the representation we want is of type box. So kind is the type box. Let's close this and run it. Over here you can see that there is a box plot created for product category office supplies, technology product, and then the furniture. Okay, so these are the three product categories that are present, and this is the box representation. You can see a median and the outliers are calculated over here. Okay, you can change this representation in multiple ways. Let's try to do that. Let's try to introduce more complexity in this particular representation. We'll represent a product category with respect to shipping mode by giving a coloring to it. So how do you give the coloring to this particular representation? We'll give hue is equal to ship mode, right? So what we are doing over here is we want these three categories to be represented along with the, of course, along with the, for the shipping cost and the shipping mode that is being used. And the kind of representation that we are interested is in the box plot method. So let's run this. So over here, you can see the diagram has changed completely as compared to that of the previous one. Over here, we just had three categorical representation. Over here, again, the shipping mode regular air is using blue representation, delivery truck is using orange, and the third one is using express air. Okay, that is the green one. So for the first category of the product, that is office supplies, regular air is used very less as compared to that of the delivery truck. And then we have express air, which is again used less as compared to that of the delivery truck. This is the first representation. So you can see that there is more details added with the help of the hewing here, right? Even in case of technology, you can see there are three sub-box plotting that is created for each of the shipping mode. And similarly for the furniture, you can see for each of them, again, there is a median and the outlier that is calculated. Okay, moving further. Let's try to make this look more better. I want to order this. I want to order it in a particular way. Okay, so I want most rather than giving this regular air, delivery truck, and express air, let us order the way in which the information is represented. How do I do that ordering? I'll just show this with a simple example. So on the same line, I will just add one more parameter to this particular chart creation, hue. And what is that I want to do? I want to order in which the data has to be depicted or portrayed. So first I want the delivery truck to be displayed. Let me put this in this particular quotes. Delivery truck. So you should know that even slightest spelling mistake will render an error for you. So we have regular air. I want regular air to be the second parameter to be displayed. And the third one obviously is the express air. Express air. Let me check whether I have closed this. Yes, let's see what will be the outcome of this particular representation. So what we have done over here is I have tried to create a box plot for the product category. We are aware that there are three product categories versus the shipping cost, and the coloring that we are providing to this particular representation is over the ship mode parameters, and the order in which the coloring has to be done and represented is first delivery truck. There is a spelling mistake. Delivery truck, regular air, and the express air. Let's see how things work here. So you can see, compare it with the previous one. You can see that we have the representation of the delivery truck, regular air, and the express air. The order in which the information is depicted has changed. The representation for regular air. Regular air is not shown here, right? Why is it so? Let's see. Okay, there is a spelling mistake here. All right, you can see that all the three values that the ship mode could take is represented perfectly. We have delivery truck followed by regular air representation. Then we have the express air representation for each of the product category. So this is about box plots. Let's see what more we can do over this. Okay, we can represent each of these separately. Let's try to do that with the way we did it in the previous case. So let's select the entire line and paste it in a new command line. And then what do I do over here? I want to represent the information row wise. So I'll use the parameter row. And set it to ship mode. Let's see what we have. So ship mode, first we have regular air. Then we have the delivery truck represented, and the third one is the. So we are successful in separating each of the shipping mode and getting new graphs. And each of these representation is again set to be row wise. Okay. And let's see what we can do further with this particular representation. You can play around with this data, and we can also have a column wise ship mode. We'll see what happens if we just put column wise. Okay, in order to understand the difference, we'll just put it in a different line. So the graphs are represented same column. Sorry, I didn't change it. So we get different graphs for each of the shipping mode, and each graph is representing one of the mode over here. So let's see. I think this should suffice about the box charts that could be used for visualizing the data. And let's move further. We'll try to understand how to generate violin charts. Creating violin graphs on the given data, which is the sales. I'll just show a couple of examples and then we will close the session. So violin, I'll just show the example and then explain what exactly we are doing over here. So same way as we represent the categorical data, use the Seaborn library, SNS, refer to it, and then use the categorical plotting and provide x-axis to be product category, and then the y-axis to be shipping cost. Of course, we are working on the data set represented as sales, and the kind of chart that we want can be represented as already told, I want it to be a violin. Violin is a musical instrumentation and it has a particular shape. That is why we call this particular graph as violin chart. Let's see the representation so that we are able to. Okay. So what do we understand from this? Now the office supply is more in this particular area, and it is having tapering and ending in a and the tail end is a straight line. And similarly for the technology, the sales is more over here, and it is again tapering, and similarly the furniture. Okay, now why do we use violin charts? Now, it is similar to that of the box plot that we have understood over there. Even here, median is calculated, and based on the density, we are trying to represent the information, isn't it? We use the density representation in order to plot this particular violin graphs. Let's see what more we can do over this particular violin graphs. Can we separate each of these graphs over the shipping mode? And if you get the hold of one of the chart or the graph representation, you can play around with it using the various parameters. Now, similar to that of the box plot chart, I will play around with this particular violin chart. So what I can do over here, I can add a new data to it, or I can add a new attribute to it, and the attribute is what? And the attribute will be shipping mode. So what I will do is I will give a hue parameter, and I will set it to the shipping mode. Now what are we getting? Let's see here. You can see that same representation of violin chart is given separately for each of the shipping mode for each of the product category, right? Now similarly, you can work on the column data, on the row representation, and so on, right? Now let me quickly run through the bar chart creation and how we can have the bar charts. That's the last one that I will be covering. Okay, creation of bar charts. Bar charts are most important in order to represent our data. I will use the same, it is again used for representing the categorical data. I'll use the same attributes which are used for the violin type of graphs. So over here, I have X as product category, Y as sales, Y, I will set it to sales. Little bit of change as compared to the previous one. sales, and then I'm referring to the data set sales, and the kind of chart that I want is change from violin to bar chart. Now let me first remove this. I'm not in need of this. First, let us put the basic chart and then try to fiddle around with it. So over here, you can see it is similar to that of the box chart or the violin chart that is created. We have 3 product categories. The mean is calculated for each of these. And then we have the representation using different colorings, right? This is just 2 values put against each other. Okay. Now let's try to add one more feature to it. I'm trying to add hue, and hue is the new attribute that I'm putting over here, which is the shift mode. So you can see that the chart is again giving detailed description about the office supplies with respect to the shipping mode and sales. So what more can be done with this? Again, I can represent the data column wise and row wise. Let us represent the data column wise by adding a new parameter or an attribute to it. Let us pull one more attribute from the data set. So over here, I will add column equal to some, let us put customer segment, the segment of people who are wishing to buy this particular product. So let's run this. There is a spelling mistake which I have done. So over here, you can see there is again different representation that we have got by introducing one more feature from the data set, or the attribute from the data set. So over here, product categories, office, technology, and furniture. And then we have the customer segment that needs to be represented. This representation with respect to shipping mode, product category is for small businesses. Then we have for consumers. Then we have for corporate and home office. So these are the 4 possible customer segment. And for each of them, the data is represented. So I can make this look more better by wrapping the columns and then changing the, let me wrap the columns and beautify these graphs. Column wrap equal to, let's say 2. So you get 2 graphs in each row when you wrap them with a value of 2. So this is more clearer than that of the previous one. Depending upon your requirement, you can just set it. And then the last option is how I get a horizontal bar graph. Now you are more adept at this. So what do? I just change the X and the Y values to represent my graphs. So over here, I will make this as Y, and the one over here, I make this as X. So let's see if we are able to get it. Yes, we are able to get it. You can see that the graphs are now horizontally represented. Now there are other possible graphs also. We have point graphs, heat graphs or heat beams. And then we have rainbow graphs and many more graphs. You can just work on each of them and get a hold of these representations. Seaborn library is one of the best libraries in Python for visualization. It is far more better than that of the Matplotlib, because of the ease with which we are able to represent the data. All right. I think we can close for today over here. Over to you, sir.
Thank you, madam. Your session was so wonderful.
Thank you, sir. Thank you so much.
And all the participants' feedback is posted in the chat box of Zoom and YouTube. You can fill it. So thank you all the participants who have attended for this FDP for all the 6 days. So let me present the vote of thanks. On behalf of Chalapati Institute of Engineering and Technology, I thank, first of all, Tanuja madam for coordinating all the resource persons. Thank you so much, madam. And next, I thank all the resource persons, Ratan Muralidhar Garu, Syed Tawheed Ahmad Garu, T. Eriswamy Garu, Dr. Shantala Devi Garu, Naveen Chandra Gowda Garu for accepting our request and making this FDP possible. Your sessions are very informative and useful for the upcoming data visualization scientists. Thank you, sir and madam. So I thank the management of CIET, our chairman, Sri Y.V. Anjal Garu, secretary, Sri Y. Sujit Kumar Garu, principal, Dr. M. Chandrasekhar Garu, and all the faculty who supported us for this workshop. Especially, I thank G. Ramchandra Rao Garu, Assistant Professor, Department of Computer Science and Engineering, for coordinating with the resource persons. Last but not least, I thank all the participants for attending the FDP and making this a big success. For all the future events, do stay in the groups and also see the community tab in the channel. Thank you so much. And the feedback link will be open for next 15 minutes. So you can fill it. Thank you.
Thank you, sir. I have shared the data set. I hope people will be able to download it and work on it. Thank you all. Thank you, sir. Thank you so much.
Thank you, madam. Those who have filled the feedback form can leave. Thank you.